This video is for day one of our mini unit. We are going to be looking at laws of exponents today. So what we're looking at are how to simplify expressions with exponents. So we're actually just going to skip down here to the bottom and we're just going to work examples. All right, so on this page, on this first one, we are doing just multiplication and division of exponents. So example 1 here, you can see that we have negative 2x squared, y to the 6th, z to the 5th, times 4x to the 5th, y to the 2nd, z to the 3rd. So we can combine coefficients, that's the numbers in front, and we can combine coefficients when the variable is the same. So to combine coefficients, we would just multiply them. Negative 2 times a positive 4 gives me a negative 8. Okay, so now we look at each variable separately. So we have x squared and x to the 5th. When we're multiplying exponents or multiplying variables with, or the same variables with exponents, we actually add the exponents together. So x squared, x to the 5th would combine to make x to the 7th. We just add them, 2 plus 5. Our next variable is a y. So y to the 6th, y to the 2nd, 6 plus 2 would give me an 8. And then z to the 5th, z to the 3rd, so I'd have the z, and then 5 plus 3 is 8. And it's just simplifying that expression down, okay? So in this one here, we're multiplying 3 pieces, 7a to the 4th times b, times 4a to the 3rd times b, times 2a to the 2nd b. So we can multiply our coefficients, 7 times 4 times 2, and if you need to use a calculator to do this, that is completely fine. So coefficients come first and just regular old multiplication. All right, our next variable is an a, and when we're writing variables down, we put them in alphabetical order, highest exponent first. So a to the 4th, a to the 3rd, a to the 2nd. 4 plus 3 is 7, plus 2 is a 9. And then we've got b. So we've got a b, and a b. So what we're doing is b times b times b, which we can write as b cubed. All right, we are going to skip to division now. We're going to skip to example 4. So what we have here is 4x to the 5th, z cubed, divided by 2x cubed, and then times z. So coefficients come first. We do that division first. 4 divided by 2 gives me a 2. And then I can break this down into the pieces. I can do x to the 5th, x to the 3rd, and then I can do z to the 3rd over z. For me, it's easier to look at each piece separately. So when we're dividing exponents, we subtract them. We just subtract the exponents. So my variable here is an x. 5 minus 3 would give me a 2. My next variable is a z. Anytime that we have just a letter, z, it's raised to the first power. So that's one of those invisible math, invisible ones. So here we would do 3 minus 1, which would give me a 2. All right, on the next one, we're actually going to multiply, and then we're going to divide. So we're going to do the multiplication in the numerator of this fraction first. So my coefficients, negative 2 and a positive 3, would give me a negative 6. X squared and x squared would give me x to the 4th, z to the 4th, and that just tacks on to the end. 2x, y, z. All right, negative 6. Ooh, mine's written different than the key. Hang on. No, we're good. Negative 6 divided by a 2 would give me a negative 3. All right, now we're going to look at the pieces. We have x to the 4th and an x. So x to the 4th over an x. Remember, that's just a 1. So 4 minus 1. Just a second here. sorry. So x to the fourth over x to the first, 4 minus 1 would give me x to the third. Now we've got a y. We've got a y on the bottom, but not one on the top. So anytime we have a fraction written like this, 1 over y, this equals y to the negative 1. So I can write that as y to the negative 1, but we try to avoid negative exponents. So I'm going to rewrite this here in a second. And then we've got z. So we've got z to the fourth over z to the third. 4 minus 3 gives me a 1. So I have just a z. So the proper way to write this one would be negative 3x cubed z over y. Anytime you have a negative exponent, that means that exponent is in the denominator of a fraction. Okay, so let's do another division one here. So 8x to the 6, z squared, over negative 2x cubed over z. So we do the coefficients first. 8 divided by a negative 2 gives me a negative 4. And then we've got x to the 6th over x to the third. So anytime we're dealing with multiplication, we can pull the factors apart. And then we've got z squared over z. So next variable is an x. 6 minus 3 is a 3. Ooh, I almost said 2. Z, remember there's an invisible 1 there, so 2 minus 1 gives me just a 1, and we don't write that exponent of 1. Okay, and then let's do this one down here. This is another compound, so we can kind of practice everything. So we're going to do the multiplication on top first. 2 times 8 is 16. Then we have an a to the third, a to the third. 3 plus 3 is a 6. Then we have a b to the fourth, b to the fifth. 4 plus 5 is a 9. So remember, when you're multiplying, you add the exponents. And then when we divide, we're going to subtract. So coefficients first. 16 divided by 4 is a 4. Our next letter or variable is an a. 6 minus 5 is a 1. We're not going to write the 1. Our next variable is a b. 9 minus 7 is a 2. All right, the next rule we're going to look at is the power rule when you're raising an exponent to a power. So again, we're just going to jump down here to the bottom. So what we have here is 4x to the fifth, y to the second, z to the third, raised to the third power. All right, coefficient first. So this expression we can break apart. We can break apart to 4 to the third times x to the fifth to the third times y to the second to the third times z to the third to the third. And we can do each piece separately. So 4 to the third gives me a 64. So that is my new coefficient. Okay, the power rule. When you raise an exponent to a power, an exponent to an exponent, you multiply. So our letter is x, and then we do 5 times 3, which would be 15. Next letter is a y, 2 and 3, so we would do 2 times 3, gives me a 6. And then we have a z, 3 times 3 gives me a 9. Okay, example 2, 4, a to the 8, b to the fourth, to the 1/2 power. So here's a little thing about exponents that are halves. Raising something to the 1/2 power is the same as square rooting it. So remember, we would do 4 to the half times a 8 to the half times b fourth to the half. So 4 to the 1/2 power. So I'm going to show you in the calculator. 4 to the 1/2 power is the same as square rooting it. Oop, a 4. Okay, so raising something to a 1/2 power is the same as square rooting it. So 4 to the 1/2 gives me a 2. 8, and so we can still just multiply these exponents together. 8 times a 1/2, or cutting 8 in half, would give us a 4. b to the fourth to the 1/2 power, half of 4 is 2. So raising a power to a power, you multiply the exponents together. Okay, so let's look at a couple other examples here. So raising something to a third is the same thing as cube rooting it. Okay, and again, you can do the exponent part in your calculator. 8 to the third, you can still type it in just like that, 8, and so you would raise it to an exponent, and that exponent you're going to make a fraction. Sorry, we don't need this piece. Ooh, try that again. 8 to the third gives me a 2, and that is the cube root of 8. So we would have 2, and then 6 to the third, you can do 6 times a third, but 6 times a third is also the same as 6 divided by 3. So 6 divided by 3 is a 2, and then 9 divided by 3 is a 3. All right, now we've got a compound one. So you've got to remember your order of operations here. You've got to remember PEMDAS. You do exponents first before you multiply. So we're actually going to do this section at the end before we do anything else. So the 3xy squared z, that all stays. 2 to the third, so 2 to the third is the same as 2 times 2 times 2, which would give me an 8. X to the 5th to the third would be x to the 15th, 5 times 3. And then z to the third, 3 times 3 would give me a 9. Then I can go back and I can multiply. So 3 times 8 would give me 24. So remember, coefficients first. We have just an x, and we have an x to the 15th, so that would be x to the 16th. Y squared, there's no y over here, so that just stays. And then z, remember there's an invisible 1 there. Z to the 1st and z to the 9th would give me z to the 10th. So remember, when you're multiplying exponents, you're just adding the exponents together. Okay, so let's work one more compound one like that. Again, to the third, just multiply 3 times 2/3 on ones like that. So let's do this compound one down here. So we're multiplying 3a to the third, b to the 4th, times 8a to the third, b to the 5th. And then this little section here is squared, so we have to do the exponent first. So the 3a cubed, b to the 4th, that all stays the same. We have to do this section first. So 8 squared, that's going to be our first piece. Remember, exponents first. Don't forget to apply the exponent or the multiplication or whatever operation to your coefficients. So 8 squared is a 64. A to the third to the second. 3 times 2 is 6. And then we've got a b. B to the 5th to the second. 5 times 2 is a 10. Now we can multiply. So we've got 3 times 64. That's going to give us 192. A to the third times a to the 6th. We add them. 3 plus 6 is a 9. And then b to the 4th times b to the 10. 4 plus 10 is 14. Okay? So when you multiply exponents, you add them. When you divide exponents, you subtract them. When you raise a power to a power, you multiply them. All right, the last rule we're going to cover are zero and negative exponents. So again, we're just going to jump right into examples. All right, 5 to the negative 4th. Okay, what this means is it looks a little bit different with variables, but these you can do in your calculator. 5, oh, why is it doing that? 5 to the negative 4th gives me 1 over 625. Sorry, it froze. 1 over 625. So what this is saying, 5 to the negative 4th is the same as 1 over 5 to the 4th. Remember, negative exponents mean that exponent or that term is the denominator of a fraction. So 4x to the negative third. This is not the proper way to write this. We try to avoid those negative exponents. So for this one, the 4 is not being raised to a power. So it would be in the numerator. X to the negative third would actually be in the denominator. Okay. All right, let's look at some more examples. All right, so here we've got a division problem, and this is usually where the negative exponents appear. But for this one, remember the coefficients first. 4 divided by 2 is a 2. X squared over x squared. This actually cancels. Remember with division we subtract. 2 minus 2 is a 0, which would leave me x to the 0. Anything raised to a 0 power, so I'm just going to do a 5 here. 5 to the 0 power leaves me with a 1. So that's the 0 rule. Anything raised to a power of 0 equals a 1. I don't need to write 2 times 1. It will still simplify down to 2. All right, this one is written really wonky. So we're going to break it apart. The coefficients, and then we've got x to the 4th over x squared, and then we've got z to the negative 5th. So I'm just pulling those pieces apart and matching them up with their buddies. So 4 divided by 2 is a 2. X to the 4th over x squared. 4 minus 2 gives me a 2. And then z to the negative 5th means that z to the 5th, we remove the negative, is in the denominator. All right, here's another one. Let's look at this one. This one's got a 0 in it. We're raising a power to a power. So 3 to the 2nd, 3 times 2 gives me a 6. B to the 0 to the 2nd, 0 times 2 gives me a 0, which would leave me with b to the 0. Again, anything raised to a 0 equals a 1. Not a b, just a 1. So we're not even going to write that term down. We don't write 1s down. They're invisible. And then we've got a c, 12 to the 2nd. 12 times 2 is 24. All right, I apologize. I know this has been a long video. That's where I'm going to stop this one for now. Just remember, negative exponents are in the denominator of a fraction. Anything raised to a 0 power equals a 1.